Welcome to this video on AutoSys Google Cloud Composer solution. In this video, we will explain Google Cloud Composer integration with AutoSys and its benefits for the AutoSys user community. We'll provide technical insights to identify the integration components and understand the deployment sequence. We'll focus on the design and execution sequence of trigger DAG run jobs in Google Cloud Composer. Finally, we'll run through a demo. Google Cloud Composer, or GCC, a fully managed service built on Apache Airflow. GCC is designed to help you create, schedule, and monitor batch workflows, making it easier to automate complex tasks and efficiently orchestrate your data pipelines. This plugin extension integrates Airflow DAGs with AutoSys, enabling seamless integration between Google Cloud Composer, GCC, and workload automation tools. Extending your enterprise automation to GCC can enhance your digital transformation with end-to-end visibility, centralized control, real-time alerting, SLA management, detailed reporting, and auditing capabilities. This integration allows you to optimize your automation efforts for improved efficiency and success. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizing these processes with other non-cloud operations. Integrating Google Cloud Composer allows us to centrally configure process automation in AutoSys. Subsequently, we can run, trigger, monitor, and supervise all processes from a single interface. These Google Cloud Composer processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to execute and monitor Google Cloud Composer jobs through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Define your Google Cloud Composer and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of Google Cloud Composer jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. The job submission sequence is relatively simple because all job definition properties are stored in the AutoSys plain old Java, or POJO job. All the target system properties, including the endpoint, token, DAG, configuration, and other parameters, are defined in the J2EE parameters. These parameters may vary depending on the authentication method used. Let's look at the sequence of execution. We start with the three main components: the AutoSys scheduler, the system agent, and the Google Cloud Composer server. The AutoSys scheduler submits the POJO job to the system agent. The system agent acknowledges the job from the scheduler and initiates communication with the Google Cloud Composer server. Authentication is then initiated, with the system agent posting token-based authentication, depending on the specifications provided in the authentication J2EE properties. In this video, we use token-based authentication. Once authenticated, the agent submits the job to the Google Cloud Composer server as a post request. The Google Cloud Composer server identifies and executes the matching job. The job execution returns a JSON response that contains the execution details. The Google Cloud Composer server and system agent monitor the job until it reaches its final state. Once the final state is obtained from Google Cloud Composer, the job status in AutoSys is updated accordingly as either canceled, succeeded, or failed. Let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses Google Cloud Composer Public REST API. Let's start by establishing communication with the Google Cloud Composer server. Once communication is established, we can proceed to execute the job. Let's dive into the world of applications and job execution within the Google Cloud Composer environment. Let's start with the demo. On the Google Cloud Composer console, you'll find a list of already created environments. Select and open any environment, then navigate to the DAGs tab. Here, you can see all the DAGs available for triggering in that environment. Open a DAG. You'll find all the relevant information, including run, diagram, code, and details. The Run tab shows the number of times the DAG has been executed. The Diagram tab visualizes the tasks within the DAG. You can also explore the DAG's code and access additional details about its configuration. Next, let's proceed to log in to AutoSys. Click the Quick View tab to view the job definition. Select the job to open the job definition. The job employs token-based authentication for the demo. When the job is open, click the Quick Edit button to view the required parameter. Select the machine on which the job is to be executed. The first parameter is the class name Airflow2 GCC2, and the second is the method name the trigger DAG-run job. Now look at the gateway parameters. Understanding these gateway parameters is an essential part of the process. The endpoint parameter indicates where the Google Cloud Composer service resides. The token parameter authenticates with Google Cloud Composer services using either a file or a concise JSON of the file contents. The DAG parameter specifies the DAG ID and configuration parameters for the DAG. Leave it blank if no additional configuration is needed. The config parameter is a custom JSON setting that controls the behavior and execution of a DAG, allowing flexible adjustments without modifying the DAG code. The run ID parameter specifies the run ID to use, with a Unix epoch timestamp appended to ensure uniqueness. The max retry parameter is crucial as it determines the maximum number of attempts the job status will be fetched from the Google Cloud Composer server for monitoring purposes. The sleep interval parameter specifies the duration of time the system agent should wait before querying the Google Cloud Composer API again to obtain the job status. In the event of a brief downtime experienced by the Google Cloud Composer service, the failure interval parameter comes into play. This parameter specifies the amount of time in seconds before failing the job due to API failure. The fail on pause parameter specifies that the job will fail if the DAG is paused before the job starts. Lastly, the log level parameter specifies the level of logging information that should be included in the log file. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the job and click Go. To confirm the job's execution, click Yes when prompted. The current run number for the job is 7744. Upon refreshing, a new execution is triggered, increasing the run number from 7744 to 7745. A status of success indicates that the last execution was completed successfully. To access the spool files, Simply scroll down on the user interface until you locate the spool files section. From there, select the desired file and click on the Go button. You will then be prompted to specify the number of lines you wish to display. Reports for all statuses are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details, run ID, and authentication parameters, are displayed. Make a note of the run ID ending with 51448. We will use this run ID for verification in the Google Cloud Composer instance. Now, let's take a quick look at the job status in the Google Cloud Composer instance. As you can see, this was the job we triggered, and it is completed. And that's a wrap for the demo on how AutoSys can integrate with Google Cloud Composer to execute and monitor jobs. Thank you for watching this video.